Hello everyone and welcome back to Band 7201 Data Visualization. This week we're going to be talking about finding and characterizing data. This will include a discussion of the different types of data and the terminology that can be used to characterize them, as well as some options for finding data and beginning to think like a data scientist or researcher to really begin asking questions of data. Recall this exercise from last week where we took a look at this data visualization from Storytelling with Data. We determined some issues with the visualization, and we looked for opportunities to revise this visualization so that its focus would be the key point of the story that the initial visualizer wanted to tell. In this case, we were trying to look at comparisons between our store and all stores when it came to specific categories. And we came to the conclusion that in order to better focus the visual, we should eliminate some of the categories, eliminate the connecting lines because categorical data does not make sense when it is connected by lines, and find a way to focus the visual on the specific story that we thought was important to our audience. We also introduced the concept of exploratory versus explanatory analysis. So in the business analytics class, you were focused on exploratory analysis, analyzing and understanding a data set in order to produce results that you would then share or use to make decisions. In this course, we may do a little bit of exploratory analysis just to refresh those skills, but then our main focus will be that of explanatory analysis, that of communicating the specific story that you found based on the data analysis that you already did. We talked about the importance of context and determining the audience to whom you would be presenting your visualization or visualizations. We use an example of a personal introduction to figure out how to target that audience, what their relationship is to you, what motivates them, and what would be important for them to know about you based on any action that you wanted them to take. We also talked about communication as having some sort of utility, meaning that every time we engage in some kind of conversation or communication, that we generally have some kind of objective. And so in this case, when we're talking about presenting data, we have that objective. We want our audience to know something, to take some action based on what we have found. This could be providing more funding for a program based on data that shows its success, for example. It is then, of course, important to make sure that you're showing them exactly the data that will be needed to convince them to take the action that you want them to take. So no more and no less. We are assuming in this course that we're presenting to some sort of manager, someone who has decision-making capabilities, and that we want them to take action based on what they are showing us, rather than pushing back and asking for either more data or a different visualization. We then started to develop the 3-minute story based on a personal introduction. We talked a little bit about how it's actually more difficult to pare down details in a story and to be concise than it is to simply ramble on about whatever topic it is that you are trying to share with your audience. So remember that in a short story, each word is very important. The author chose that word for a specific purpose to get a specific point across to the reader. And the same applies here. So when we're thinking about presenting a story based on a visualization or several visualizations, we want to keep in mind that 3 minutes should be ample time to briefly summarize exactly why they should care, what the main point is, and the action that we want them to take. We also engaged in the process of storyboarding using sticky notes. So the sticky notes are useful because they allow us to swap things in and out, to avoid attachment to any work that we've previously done, to allow us to freely explore and brainstorm and edit, and give ourselves feedback or get feedback from others about what we have planned in our presentation. We will continue to use this process throughout the course. The learning objectives for this week are as follows. So after this week, you should be able to identify and explain the characteristics of various types of data, specifically each field in a data set. You should be able to identify sources of online data that is publicly available and be able to find datasets relevant to a research question. Let's begin by looking at a simple taxonomy of data. You may have already come across these terms in a previous course. In my experience, I think that being able to categorize the specific types of data you have in a dataset is the key to understanding the kind of analysis that you can conduct on that data, as well as what types of visualizations will best serve that data and your audience. In this course, we're going to focus on this side of the tree, so starting with the idea that our data is structured in some way. It may already be contained in a CSV format, for example, or in a database. We have two types of structured data, categorical and numerical. And we're going to talk about the different categories of each. Within categorical data, we have nominal and ordinal data, and within numerical data, we have interval and ratio data. We'll talk about the details of each shortly. The first of the categorical data types is that of nominal data. So nominal data is categorical data that is unordered. For example, categories of food at the grocery store. So we consider that we have canned groceries, we have frozen groceries, we have produce, and we have dairy. We may have other categories, but you can see that there's no specific ordering to these categories that presents itself. There is no ordered relationship to dairy or produce, etc. If we have categorical data that has a natural ordering, we have what's called ordinal data. So as opposed to nominal data, which has no inherent ordering, ordinal data has an ordering. So for example, we have the Likert scale, which is ordered from 1 to 5. Now these numbers aren't treated specifically as values, but rather as categories with an order. So be careful when determining whether your data is ordinal or is one of the numerical categories, as you want to first make sure that if it is numerical, that the number actually has meaning as a number. In the case of the Likert scale, it is ordinal because while we have order, each of these numbers doesn't have specific meaning as a number. Level of education is another example of ordinal data. We do have an inherent ordering as people generally complete their education in a specific order. For example, high school, then college, then maybe graduate school, and we can arrange those categories in a specific order. So while we could assign numerical values to each of those categories, again, they don't have inherent meaning as numbers. They are just representing the order of the categories. Moving on to the numerical data types, we have two. So we first have the interval data, where the interval to every point of measurement is equal to every other. So you have equal intervals, and 0 is not an indicator of an absence of the thing that you're measuring. So for example, if we're on the 24-hour clock and we're thinking about time of day, 0 represents the start of the day or midnight and does not represent an absence of the thing that we're measuring. So it's not like 11 a.m. indicates more of time of day versus midnight. In contrast, another type of numerical data is ratio data. So ratio data include height, weight, age, money, any numerical data that has a meaningful 0 point. So for example, in the case of money, if we have 0 money that has meaning, it represents an absence of money, rather than an interval along a range. So let's take a look at this table of data. What I'd like you to be able to do is when you find a data set online, that you are able to look at every field and determine what type of data that field contains. So first determine, is it categorical data or is it numerical data? And then once you've chosen which one of those it is, further drill down. Is it nominal or ordinal if it is categorical data? Is it ratio or interval if it is numerical data? So take a minute to look at the data. You can feel free to pause while you try to determine which data type each of these fields represents. I'm going to skip the first field and move straight to section. We'll come back to that in a second. So if we're looking at section, this is similar to the first example we saw. We have no numbers, so that helps us understand that in this case it is categorical data, first of all. Then we just have to decide whether or not there is an ordering to it. And taking a look at these produce, dairy, frozen, canned, we can see that there is no order, so this is going to be nominal data. If we take a look at the next field, aisle, we have numbers, but we need to be careful. First, determine whether or not these numbers have meaning as numbers themselves. In this case, they do not. They're simply referring to which aisle we are in. This is categorical data, and because it is ordered in the order of the aisles, we are looking at ordinal data. Looking at the next field of quantity, we have numbers, and quantity has meaning as a number. So we know that we are looking at numerical data. The question is now, is it interval or ratio data? So we need to determine, does 0 have meaning as the absence of whatever the field represents? In this case, 0 would indicate that we have an absence of quantity of that item. So this is in fact ratio data. Finally, if we take a look at cost, cost is money, which we already said was numerical data. And 0 does indicate an absence of money. So in this case, we are also looking at numerical data. If we head back over to the item field, There are a couple of things we can do with this. First of all, you can see that we have an opportunity here to split the data. It looks like oranges is stored with pounds, apples is stored with pounds, that some of these have a unit of measurement. And we probably want to separate that out, do some cleaning and move that into a separate column. But since these are items and are not ordered, we could consider this to be categorical data that is nominal. So I can't stress this enough. I think that it's very important for you to be able to take a look at a data set that you found, look at every single field, and be able to tell what kind of data it is. And the reason for this is that specific types of analysis and specific types of charts and visuals can only be applied to certain types of data. So the first step in being able to create a good visualization or to be able to do analysis on a data set is that of identifying the type of data that you're looking at in a specific field, and then determining whether or not you need to clean that data. The next thing I want you to be able to do is really begin thinking like a data scientist. So thus far, you may have been given data to look at or data to analyze and have been told exactly what to do with it and why it is interesting, or why it should be interesting to you. And I think for some of you, you may have already looked into data sets that are related to topics of interest to you, for example, sports. But if that's not something you've done before, I'd like to encourage you to begin thinking about your day-to-day activities or your interests. So forget about class, forget about data for a moment. So when you're browsing the internet, interacting with family, friends, watching sports, playing games, or going to the store, are there things that you observe that make you say, I wonder why that is? So one of the key aspects to thinking like a data scientist is having that natural curiosity about the phenomena in the world around you. Being able to see potential relationships between things in the world and knowing how to find the data to either support or contradict your theory after formulating a theory. For example, once when I went to the grocery store, I noticed that while I was near the produce, specifically the fruit, that next to the fruit, the store had decided to place candy that was shaped like fruit. So given some natural curiosity and experience conducting research, I thought, well, that's interesting. I wonder why they place those two items near one another. It could be a coincidence, but it also might not be. And from your past experiences, you probably realize that teasing out correlation versus causation can be an issue. But the point of the matter is, I saw something in the world, it was interesting to me, and I wanted to investigate it. So if I were to begin my process of thinking like a data scientist based on my observation that this particular store stocked candy that looked like fruit near real fruit, I would first write down my observation. So the fact that I had observed candy next to real fruit that it looked like. I would then start to think about why the observation was interesting to me. So this can be twofold, really. It could be personally interesting to me, or it could be of interest to me as a consumer. It was interesting to me personally because I do take an interest in the nutrition of the food that I eat, and thought it was interesting that candy was being stocked next to fruit. That seemed out of place to me. On the other hand, I thought, well, perhaps that was done intentionally. I'm, in fact, pretty sure it was, but I don't know that yet. And thought that it was interesting that a store would go through the trouble of doing that just to increase the sales of the candy. I think my hypothesis was basically that if somebody coming through thought about buying fruit and then perhaps thought better of it, that they might just purchase the candy instead, the store still gets a purchase out of it, and the consumer feels like they've made perhaps a good choice. The third question, so why might this observation be interesting to someone else? This gets into generalization and really finding out if there are applicable rules, in this case, association rules that could be applied in another store. So it's interesting to me because I'm interested in nutrition and human behavior. It'd be interesting to someone else, perhaps the target audience of the manager of the store. If we were to investigate it, perhaps they would learn that, in fact, there was an association between these two items. And we could look into it further to increase their profits. The fourth point here is probably the most difficult one, and that is developing a research question based on the observation. In the case of data analytics, very often we don't have an initial question, other than we want to explore the issue. We want to see if there's something there. Is there a relationship there? And are there techniques or visualizations that can help us get insights from the data? The research question might also depend, for the purposes of class, what types of analysis and what types of visuals that you're comfortable working with. We'll continue to explore the research question process throughout the course. For now, looking at it from an analytics or visualization standpoint, you can simply ask, is there a relationship between, say, the purchase of produce or the lack thereof, and the purchase of the candy that's related to the produce? And there are different methods that we could use to investigate that. For the last question, how might you answer the question you're posing? This is where the data sets come in. So it may be that you have the ability to conduct experimental research out in the field. It may be that you can conduct a survey. For the purposes of the course, we're going to be looking for online data sets that are representative of the phenomena that we are looking at. So we might try to find related grocery store data and see if we can get some data that would actually be related to the question that we're asking. Here is a list of several online public data sources that is quite useful. And I recommend that you start by looking at specifically the UCI Machine Learning Repository or the Kaggle repository. So for Kaggle, you do need to create an account, but it is free. For UCI, everything there you can just access for free without creating an account. So let's take a look at the UCI Machine Learning Repository. If you go to the main page to get to the list of all the datasets, simply click View All Datasets and it will take you to this page. Now what's nice about this is that they are classified as the different kinds of analysis that you can conduct on each of these datasets. So let's take a look first at how they are classified. First, we have whether or not we can use classification, regression, clustering, or other techniques on these datasets. If the types of attributes or fields within the data are categorical, numerical, or both. We have the domain, the number of attributes, the number of instances or records, as you're probably more familiar with, the format of the data, and then finally the data type, which we'll get into a little bit later. So let's take a look at an example. I'm going to go to a numerical dataset by clicking on numerical, and you'll see that it highlights it on the left, so I can actually choose additional data types. I'm going to look for less than 10 attributes. So attributes, that's going to be the number of fields across. Keep it a little bit simple. And I'm going to start to browse. So as I'm browsing, I can take a look at a couple of sets. I'm going to click on the iris set, and you'll see that you can download the data folder and the dataset description. This is a very famous dataset that's used for the purpose of classification. If I scroll down, I can see all the attribute information. So we have here the sepal length, the width, and the petal length and width, and then the class. So what I'd like you to be able to do is take a look at each of these fields and be able to tell what type of data it is. Is it, first of all, categorical or numerical? And then further drill down into whether or not it's nominal or ordinal, interval, or ratio. I'm going to go ahead and get the data. So click on the data folder to download it, and click on Iris Data in order to download it. Now I had to use Open With in order to open this in Notepad. It looks like it's comma delimited, so I could also open this up in Excel as a CSV and convert to an Excel file if I would like. So a couple notes here. I'd like you to be able to open datasets. So you may either need to use Notepad or some version of Excel, will depend on the type of data. Most of it will be comma delimited. And then be able to look at each field and determine the type of data that it is. For the purposes of asking a research question, there are several questions I could ask here. I could see if based on these inputs, if we could classify the type of flower that it is. I could also investigate whether or not there's simply a relationship between the sepal length and the petal length, for example, or the sepal width and the petal width, etc. The one caution I will make to you is that when you are exploring data sets, make sure that they are not aggregate data sets. If they are aggregated, you'll need to do some additional cleaning. So I don't want to deter you from using data sets that contain aggregates, so in other words, averages across different populations, things like that are not broken down into individual records, but you will have to use a dummy coding procedure in order to convert that aggregate data into deaggregated data, either for the purposes of analysis or for visualization. After looking through several data sets, I'd like you to then begin to do the following. So after you kind of get an idea of what's in the data set and what types of data you're looking at, try to think about, is there a possible relationship between or among the fields in your data? That's one route that you might be able to pursue. Why might that relationship be interesting to you? Why might it be interesting to someone else? See if you can develop a question based on your observation. In the case of the flowers, it could have been simply, can we classify the type of flower based on the inputs that we have, these measurements of the flower? And in order to answer the question, we could do some visualization. We could also run a classifier in order to obtain that information. That's going to depend on the type of data that you have. But at the end of this week, I would simply like you to be able to find data, to start to think like a data scientist while you're looking at that data, and be able to classify the different data types that you have in those fields. If you can do that, then you'll be able to create applicable visualizations, as well as be able to conduct appropriate analysis. If you have any questions about these topics or about finding data sets, please let me know.